power source. Power source is what makes all electrical system, equipment, and devices come to life. As a hobbyist, it is very important to have a strong foundation on such concepts because there is no such electric circuit or system that will run without it. To learn more in detail what electrical power is, in this video we are going to talk about the following. 1. What is electrical energy? 2. Why power source has two terminals? 3. Components of power. 4. Types of power. 5. Examples of power source. 6. Choosing the right power source for your application. Energy is the capacity to do work. Wait, I said I will make this easier, right? So let's consider you as an example. Say you pick a bucket full of water and you walk about 10 steps. It means you just created work, literally. Energy is the ability to do work. If you have lots of it, you have the ability to carry the bucket at very long distances. This means also that power in this example has two components. The amount of strength you exerted and the height of the bucket is lifted. In an electrical system, the power is you. The electrical circuit is the bucket full of water, and the total distance you walk carrying the bucket multiplied by the power you exerted is what we call energy. Power, which is a unit of watts, is the product of two components, voltage and the current, given by this formula. P is equals to VI. Voltage has a unit of volts, while current has a unit of amperes. Energy, on the other hand, is the product of power and time. Having watts per hour as its unit, in other words, energy is the measure of power delivered in a span of time. To make it clear, suppose you have a washing machine rated 1,500 watts and you operated it continuously for 1 hour. That means 1,500 multiplied by 1 is equal to 1,500 watts hour. If you're going to convert it into kilo, a standard binary prefix, it's going to be equal to 1.5 kilowatt hour. To convert it into actual electric consumption, suppose your electricity rate is 10 pesos per kilowatt hour, then the cost of your electricity to run your washing machine in an hour is 1.5 times 10 pesos, that is equals to 15 pesos. So now, you have already grasped what is energy and power in electricity. In a nutshell, an electrical energy is the amount of electrical power used in a specific span of time. Our electric utility records our electricity consumption on a monthly basis, and they do this by means of our electric meters. Since we already talked about energy and power, let us learn how it is being connected into our electrical system, device, or equipment. Since we are just starting out, let us leave the three-phase system on a future discussion. Every power has two terminals, line 1 and line 2, and every appliance, machine, equipment, and devices, which we now refer to as load, has two input terminals as well. To know where to connect each wires of the source and load, we will first consider the two types of power, the DC or the direct current, and the AC or the alternating current. First off, the DC is a type of source where the voltage and current is steady on a specific level all throughout a given time. It will not change. On the other hand, AC current is opposite to that of DC, as it is varying. Looking back at the graph, you can see that the DC shows a straight line while the AC is a form of a wave, which is called a sinusoidal wave. It varies as time progresses. In an AC, there is what we call one full cycle, which is divided into positive half cycle and negative half cycle. The number of full cycles that occurs in 1 second is known as frequency, which has a unit of hertz. The most popular frequency is the 50 and 60 hertz. Since DC flows steady, we can safely assume that it flows in one direction. This is why DC source has its polarity. You cannot reverse the connection Otherwise, your load will not run or operate, or in worst cases, get burned. Meanwhile, in AC, since the flow of current is varying, we can say that the flow of current changes direction in every half cycle. This means that in an AC system, you can interchange the connection of the two terminals. So now let's consider some examples of the two types of power source. For the DC, we have the battery, a DC motor used as generator, PV or solar panels, and others. For the AC, the 100 or 240 volts wall outlet, transformer, and AC generators. Now, let's talk about how to choose the right power source. In most electronic boards, the supply is usually DC. Whereas for large applications, such as motors, electric distribution network, and industries, AC is commonly used. Most equipment and devices specify the type of source it needs and it cannot be changed. If it's AC, then use AC. If it's DC, use DC. However, there is one aspect that we can manipulate assuming that it is the required type of power source. That is, power rating, voltage rating, and current rating. To generalize the most common question regarding power source, let us consider these three example questions. 1. Can I supply 100 watts to my device which is rated 20 watts? Second, can I use 220 volt supply with my device rated 110 volts? 3. Can I use 10 amp supply to my device which is rated 50 amps? Let's summarize our answer into these three factors. 1. The supply voltage should be equal to the required voltage of any load. 2. The load rated power should be 70% to 80% of the power supply rating. 3. Ampere rating of the load should not be larger than that of the power source. So to answer those three questions, can I supply 100 watt to my device which is rated 20 watts? The answer is yes. Since power is the ability to do work, by common sense, the power source must have greater capacity than that of the load. Second question. Can I use 220 volt supply with a device rated 110 volts? Absolutely not. The most crucial specification in electronics is the voltage level. 3. Can I use a 10 amps supply to my device rated 50 amps? Yes, but the device might not work at 100%. This is the concept behind slow chargers and fast chargers. The higher the ampere rating, the faster you can charge. More about this in details when we talk about the types of connection. That's it. On our next video, we will learn the different types of connection and how it affects power, voltage, and current. If you liked the video, please give it a thumbs up and do subscribe. I will be very happy to have you around. I will be posting new videos every week, so be sure to click the bell button so you won't miss any of my videos. Remember that learning by heart is way better than being naturally smart. See you in my next video, only here at Home Innovations.